Welcome to Cambridge P1 topical questions, and we are going to look at functions and transformation. Basically, functions and transformations is the second chapter in P1 Cambridge edition A and AS level, and this is supposed to be paper 2 note 1. So we are going to look at this mathematics code 9709, basically on function and their transformation. So we are going to start with a simple equation. So here you are supposed to solve the equation 3x plus 2 equal 2 divided by x minus 1. Very quickly, as you see the equation, you can easily multiply both sides by x minus 1, the denominator, and also x minus 1 on the right hand side, such that this x minus 1 and x minus 1 cancels out, and we are left with 3x plus 2. So we have 3x plus 2, multiply this by x minus 1, x minus 1. So this is equal to 2 that is left on the right hand side. When we expand this, we are going to have 3x squared minus 3x plus 2x and minus 2. So this is equal to 2, right? That is equal to 2. Let's now take this 2 to this side. We are going to have 3x squared minus 3x plus 2x minus it becomes negative 4. So this is equal to 0. We have negative 3 plus 2, so we are going to have 3x squared. It becomes negative 3x plus 2x will give us negative x. So this is negative x minus 4. So this is equal to 0. You can solve this quadratic equation using the quadratic. We can solve by factorization. We can look at what is AC. AC is 3 times negative 4. This gives us negative 12, right? So which two values can we multiply and get negative 12 and add them and get B, which is negative 1? In this case, represent negative x. It will be negative 4 and 3. When you multiply negative 4 and 3, you should be able to get negative 12. And when you add negative 4 and 3, you should be able to get negative 1. So we replace this negative 4 and 3 in B, where you see B. So this is our A value, B value, and C value. So if we solve now, what happens is that we are going to have 3x squared. Instead of negative x, we are going to have plus 3x. We replace with these two values, plus 3x minus 4x, right? Minus 4x. Then we are going to have minus 4. So this is equal to 0. At this point, you can group it. We have 3x squared and 3x, and we have negative 4x, and then we have negative 4. So if we group this, if we try to group that, we are going to have let's factor out 3x, and then we still have x plus 1, and here we can factor out negative 4. So negative 4, and we are left with x plus 1, right? We are left with x plus 1. So this is equal to 0. So we can take one outside the bracket and one inside the bracket. The one outside the bracket is simply 3x minus 4, and one inside the bracket is x plus 1, right? So we can solve these two now to get the value of x. So when we take 3x minus 4 to be equal to 0, we simply take 4 to the other side. It becomes positive. So this is equal to positive 4. Divide both sides by 3 so that x is equal to 3 over 4. So this is one value of x. Now let's take the second. X plus 1 equals 0 implies that our x is nothing but -1. So the required solution to this question is either x is 3/4 or x is -1. So let's proceed to the next question. So this is, we have solved the first question. B, which in this case there is issue in numbering. You are to express x squared minus 8x plus 11. And just before we solve this question A, express x squared minus 8x, let me take you back a bit to the previous question. We got here 3x, this is divided by 3, so it is 4/3, not 3/4. So note that is 4/3 because we divide both sides by 3 by 3. So the right answer here is 4/3. Right, so let's proceed to the next question. So here we are to express x squared minus 8x plus 11 in the form x plus p squared plus q. So this will be completing the square, right? And we did this in quadratics on how to complete the square. So you know, by conceptual understanding, you will take the b value and half it, then square it. So actually what we have x squared minus 8x plus 11. So if we have this in the form x plus p, the required is for us to put this in this form, x plus p squared plus q. So we are going to complete the square. What is half of 8? It is 4, and 4 squared will give us 16, right? So simply have x minus 4, which is half of 8, square this, then the square root of 4 is 16. So we are going to have minus 16, then plus 11. So the required solution is x minus 4 squared, then negative 16 plus 11 gives us -5. As easy as that. So this is the required solution to that. Alternatively, I can give you alternative method of doing this. If we have in the form x plus p squared plus q, this can be equal to x squared 2px, this is plus 2px plus 2px plus p squared plus q, such that we look at, we compare the coefficients. The coefficient we have for x squared is simply 1, right? So it is 1, and it is equal to the coefficient we have on the other side, which is also 1, right? For 2p, when you compare the coefficient of x, we had 2p here. So if you compare both left and right, we will have 2p is equal to 8, right? 2p is equal to 8. If you solve for p is going to be -4. And what are the constants in these equations? The constants are p squared plus q. This is equal to 11. such that we can have p, which is negative 4, so it is negative 4 squared. Negative 4 squared plus q is equal to 11. Negative 4 is simply, we take this, 4 squared is 16, right? 16 plus q is equal to 11, right? So q will be equal to negative 5. So you can solve. You can see here we got negative 5 for q, and we also have 4. So you can solve using any of these methods, but you can just see it is very simple and direct in the first method. Now, hence find the exact solution of the equation. We want to find the exact solution of the equation as required, and that is easy 2 marks. So we have x squared minus 8x plus 11. So this is equal to 1, right? So if we try to, from A, we completed the formula. Completing the square, we have x minus 4 squared minus 5. So this is equal to 1, right, from A. So we are going to have x minus, so this is x minus 4 squared. X minus 4 squared is equal to 1. When we take negative 5 to the other side, it becomes 6, right? So x minus 4 is going to be plus or minus the square root of 6, because we want to remove these squares. So we can take 4 to the other side so that we find x. X will be 4 plus or minus the root of 6. So this is the required or the exact solutions of the equation. So it is either x is plus root 6 or x is minus the root 6. Question 5, you are supposed to express 2x squared minus 8. 2x squared minus 8x plus 14 in the form 2. So here we are still working with completing the square. So the required, we have 2. Can put this into bigger bracket because it is 2x squared, so we can have x minus a squared plus b in this form. So this is equal to, let's factor out this 2. It is 2 into x squared minus 2x or minus 2ax plus a squared plus b, right? So what happened is that this becomes 2x squared minus 4ax plus 2a squared plus 2b plus 2b. So we can take this 2x squared minus 4ax plus 2a squared plus 2b to be equal to 2x squared plus 8x that we have, that is minus, not plus, minus 8x. So we have 2x squared minus 8x plus 14. Plus 14, right. So we can compare coefficients for x squared and use a different color. For x squared, the coefficient here is 2x squared and we have 2x squared. So it means that 2 is equal to 2, right? Let's compare the coefficient of x. The coefficient of x is negative 4a. So we have negative 4a. Negative 4a, and this must be equal to negative 8. So we can find what is a. You divide by negative 4, so a is simply 2, right? Let's compare the constants. The constant, we have 2a squared on this side, so 2a squared plus 2b, right? This is equals to 14 that we have on this side. So when we solve, what is a? A, we got 2, so simply replace that. So this becomes 2a squared is 2 into 2 squared plus 2b. This is equal to 14. So we are going to have 2 by 2 squared gives us 8 plus 2b equal 14. So 2b is equal to 14 minus 8. We are going to have 6. So b is equal to 3. So in the form required, we are supposed to have it in the form 2 into x minus a squared. This becomes 2 into x minus 2 squared plus our b value is 3 here. So this is the required solution for this question. And that is your 4 marks. Let's proceed to the next question. Express, you are supposed to express 4x squared minus 24 24x plus p in the form a into x plus b squared plus c, where a, b, and c are constant. Of course, they are integers to be given in terms of constant p. Again, this is completing the square, so we simply have 4 into x squared minus 6x plus p. Right. So 6 divided by 2 will give us 3. 3 squared is 9. So it is 4 into, we are having x minus 3, the half of 6. Then square this, and the square root is 9 minus 9. Then plus p. Plus p. Right. So the final answer becomes 4 into x minus 3 squared minus 36 plus p. Next question. Hence or otherwise find the set of values of p for which the equation 4x squared minus 24x plus p equals 0 has no real root. Of course, it takes you back to the discriminant conditions. if it has no real root. If it has no real root, discriminant tells you that b squared minus 4ac must what? 4ac must be less than 0, right? Less than 0. So if we use this here, we are going to have our b in this case is negative 24. So this is a, b, c. So our b is negative 24. We have negative 24 squared minus 4ac. Our a is 4 and our c is p. So this must be less than 0. That must be less than 0. Negative 24 will give you 576, correct? 576. Use your calculator if you doubt that. Then minus the square root 4 by 4, 16. 16p, right? So this is less than 0. So 16p therefore, negative 16p is less than negative 576. So what is 16p? It is, if you remove that negative, it becomes greater than 576, and p is going to be greater than what? 36, right? Required solution. Look at the next question. 16x. So we have 16x squared minus 24x plus 10 in the form 4x plus a squared plus b, again completing the square. So we have 4x plus a squared plus b to be equal to 16x squared plus 8. We have 8ax plus a squared plus b. That is if we open this up. So it means that 16x squared plus 8ax plus a squared plus b must be equal to the given equation or the given expression 16x squared minus 24x plus 10, right? So let's now compare coefficients. When we look at x squared, the coefficient of x squared in this case, when you look at the coefficient of x squared is 16 and here is also 16. So it means that 16 is equal to 16, right? Let's compare the coefficient of x. We have 8ax, so we have 8a, and that must be equal to negative 24. So solve for a divided by 8, so a is going to be negative 3. And let's compare the constant. The constant we have a squared plus b, that's equal 10, right? What is b? A is negative 3, so negative 3 squared plus b equal 10, and 3 squared is 9, so 9 plus b equal 10. So b is what? B is 10 minus 9, which is 1. So in the required, we are required to leave the answer in the form 4x plus a squared plus b, and we already got 4x, so it is 4x. It is 4x minus 3 squared plus our b is 1 plus 1, the required solution. It is given that the equation 16x squared minus 24x plus 10 equal k, where k is a constant, has exactly one root. Find the value. It has exactly one root. So if it has exactly one root, the discriminant b squared minus 4ac must be what? Equal to 0. It has exactly one root. So in this case, 16x squared minus, so we have 16x squared minus 24x plus 10 take this k to that side, it becomes minus k. This must be equal to 0. So if we use the discriminant b squared, so this is ab, right, and c. So b squared in this case is going to be negative 24. Square this, negative 24 squared minus 4ac. 4a is 16 and c is simply 10 minus k. So this must be equal to 0. Negative 24 squared is 576. So 576 minus 4 by 16 gives us 64. 64 into 10 minus k, and this must be equal to 0. Equal to 0, right? So we have 0. Again, now we can look at 10 by 64. So we are going to have 576. Can create more space there. So we have 576 minus, what is 64 by 10? 64 times 10 gives you 640. So this is minus 640 plus 64k plus this is minus, right? So it is plus 64k. This is equal to 0, right? So now what happened is we have negative 64 so we have negative 64, that is 576 minus 640, negative 64 plus 64k must be equal to 0. So 64k is equal to what? 64 positive. Divide both sides by 64, so k is equal to 1, right? K is equal to 1. So we have 16x squared minus 24x plus 10 originally given to be equal to 1, right? And we have seen from A that 4x minus 3 squared plus 1 is equal to 1. So 4x minus 3 squared will be equal to 0. So 4x minus 3 is equal to 0 implies that 4x is equal to positive 3. So x is nothing but 3 over 4. Right. So we have functions f and g are both defined for x as a member of R. So x is a member of R representing real numbers, and they are given in this function f of x and g of x. So f of x as a function is given as x squared minus 4x plus 9. G of x is given as 2x squared plus 4x plus 12. So we are supposed to express f of x in the form x minus a squared plus b, again completing the square. So very easy, just like the previous one. For f of x we have, so it is x squared minus 4x plus 9. So if we express it in the form, we are going to have x minus the half of 4 is 2 minus 2 squared, then minus 4. 2 squared is 4, then plus 9. This will leave you with the answer x minus 2 squared plus 5. Right. Express g of x in the form 2 into that. So let's look at it. 2 into x plus c squared plus d. So we have 2x squared plus 4x plus 12, which is our g of x. So this is equal to 2 into x squared plus 2x plus 6. Right. So we are going to have, by simplification, 2 into, if we complete the square here, this becomes 2 divided by half of 2 is 1. 1 squared is simply 1. So we are going to have x plus 1, then squared, then minus 1, because 1 squared is 1, then plus 6. So this becomes 2 into x plus 1 squared plus 5, the required answer to the given question. Here we are having the next question. Express 5y squared minus 30y plus 50 in the form 5y plus a squared plus b, where a, b are constant. So here we are given, we have 5. So you have 5. Then we have y squared minus 6 squared. This becomes minus 6y, right? By simple factorizing, you factor out 5 here. We have y squared minus 6y, because we know 5 by 6 gives us 30. So we are left with 50. So this is plus 50. So let's do a little simplification. We are going to have 5 So it becomes 5 into y minus 3, the half of 6, then square it, and square root of 3 is negative 9, then plus 50. So finally we are going to have 5 of y minus 3 squared minus 9 plus 50. We have negative 45 plus 50. So that you can have your final answer as 5 into y minus 3 squared plus 5. Find a set of values of k for which the equation 8x squared plus kx plus 2 has no real root. Discriminant. Okay, so for us to find that for which it has no real root, discriminant is b squared minus 4ac. It must be less than 0 for it to have no real root. So here is a, this is b, and this is c. So let's see. If we do k squared minus 4ac becomes 4a is so we are going to have 4 by 8 times c, which is 2. So this must be less than 0. If we do k squared minus 64, 4 by 8 by 2 minus 64 must be less than 0. So k plus 8 and k minus 8. K minus 8 must be less than 0. So the critical value k is simply k to be equal to negative 8 and k to be equal to 8. And you can as well show this graphically. So you can put it as negative 8 less than k less than 8. So you can see all these questions is relating you to functions and transformations using the discriminant. And this will be the end of this video. We will be looking at now other questions that involve functions and transformations in the next video.